Okay, let's begin. So in mute. Okay. So yesterday we discussed about what? We discussed about uh, Spark and Pyspark differences and what are the differences if you run the code in local Pyspark as well as in the Databricks. So why we need Databricks, when it is mandatory, when it is not mandatory. So everything we discussed in the last class. So we will continue with today. Let me share my screen. And once you start the PySpark session, see, see. So this is what you tried yesterday, right? This is what you tried, but you told you are not getting this message. A Spark session started successfully. So since I have made the setup, I am getting this output. Okay. So once you start the Spark session, okay, once your Spark session has started successfully, you can view the Spark UI. Okay, how do you view the Spark UI? Just go to this localhost 4040. Okay, so this is the Spark UI, how it looks. See, jobs, these are the jobs. See, blue color represents added jobs. Since we don't have any jobs, I'm not getting anything here. Okay, I have just started the Spark session. That's it. There are no jobs. Okay, so blue color represents added jobs, red color represents removed jobs. Okay, and here when you come to the lower part, so blue color represents the succeeded jobs, red color represents the failed jobs, and green represents the running jobs. Okay. So this is about all the details about the jobs. If you are running any job, if you are not running any job, it will be empty. Okay. And it is showing you who is the user, when does this Spark session started. So right now I started the Spark session, right? So it is showing me the time 11:33:44 right? So the time when did I start the Spark session, and total uptime. So it is 3 minutes since I started the Spark session. Okay, and scheduled mode FIFO, first in first out. It always works in the FIFO mode. Okay, now come to stages. So if since I don't have any jobs, I don't have any stages here. Okay, then it comes to storage. Storage is also not there. When you come to environment, here it will show you where is your Java home path, which Java version you are using, which Scala version the Spark is using. Everything in environment it is showing. Okay, and what are the Spark properties? Start time, submit time, some ID and name. So the name what you have given when you started the Spark session. So you gave my app, right? So that my app is showing here. Spark app name. So if you go here, you can see app name you have given what? My app. So if you give any other name, that name will be appearing here. Okay, this is the Spark name and this is the Spark ID. Okay, so this is the Spark ID. So here if you want you can expand this. Okay, so all the details. So you want or not, it will display all the details regarding the Spark resource file. So if you are having any resource profiles, it will show here. So just you know that what are the things present in the Spark UI. That's it. Okay, this Spark UI we also have in Databricks. Okay, but here I am showing it in the basic Spark UI now. Then coming to executors. Executors, I told you, these are the number of machines or CPU cores where you are running the tasks. Okay, so these are the one active executor is there. Okay, dead executors 0. Okay, so only one executor I am having here, and down you can see the driver. Okay, so where the driver has been installed. So the driver has been installed in my system. So my system name is desktop HBNH. So this is my system name. It is showing that. So active task, failed task, completed task, everything it will show you. So it will show once you run the tasks, run any jobs, you create anything, something you do, it will show. Okay. So this is how it looks. Your Spark UI looks like this. So once if you stop the Spark session, you cannot be able to see the Spark UI. Since I have started the Spark session, I am able to view this. Once you stop it, you will not be able to view it. I will show you. I will stop this Spark session. So what is the code? Spark.stop. Wait, I'll show it. So now it is started successfully. Now I will stop. Okay, I hope it is stopped. Now I go to this, refresh. See, I'm not able to see this because Spark session has been stopped. Now again I start the Spark session. I'll run the same code. Now it is showing me Spark session started successfully. Now go to this UI, refresh. You will be able to see the page. Okay, like this it works. Okay, so the same thing now I will show you in the Databricks. So this is my Databricks session expired. I need to log in. So you might not get the response so fast in Databricks because it is the online platform, right? So in Jupyter Notebook you will get it fast, but in Databricks you might experience some delay. Let me verify. Now this is your Databricks homepage. Okay, if you have created the Databricks account, you will be able to see this homepage when you open the Databricks. Okay. See, it takes some time to load. See, the same code what I have written in here also you can create the notebook. How do you create the notebook? Go to new. Okay, go to new. Here you have notebook option, right? Go to this notebook option. See, new notebook is created. Just like in your Jupyter notebook. Here also you can create the notebook. Now since I have already created the notebook and pasted the code here. So here you have run button, right? Click the run button. So this was I executed before. So now I'll run it once again. See, it is showing waiting. Okay, just now it has done. Spark session started successfully. See here there are no problems at all. No version problems, nothing. So you can simply run the code. It will take some 2 to 3 seconds of delay. That's it. It will give you the output. Okay. No headaches in the Databricks. Okay. If you are not getting it in the Jupyter Notebook, please try it in the Databricks. Okay. You will definitely get the output. So Spark session started successfully. Okay. So right now you just know how to create the notebook, new notebook, and how to execute the code. So just like Jupyter Notebook, here also you have the cells here. Okay. So you have this, insert the cell above and below, cut, copy, delete the cell, all the options you have. Suppose you want to execute some other code, insert the cell below you can give. Here you will get the another cell. Okay. Another code you can run here. Fine. Just like in the Jupyter Notebook. Okay, and here you have workspace. So by default you will be having the workspace. Okay, see this is my workspace. So I have these many notebooks created. Okay, if you go to this workspace, you will have repos, shared users, all these things you can find. This is my repo. Okay, shared repos. If you are collaborating with the other team members, so if they share any repos, that will be available here, all these things. Okay, so practice in Databricks running the code, then you will become used to it. Okay, fine. Now let us move on to our this thing. Now we got it, how to create the Spark session, right? So if not working in Jupyter, just go to Databricks and create the Spark session. Okay, fine. Now, so where you can view the Spark UI? It is localhost 4040. This is the URL where you can view the Spark UI. Just now I showed you know that one. Okay. So what all the things you can find here? You can find jobs and stages being executed. Okay. And you can find the storage and memory usage, how much storage and memory it is used, and time taken for each task, and environment settings. That also I have shown you, right? Environment settings, executors, how many executors running your task, and also it shows about RDD or data frame lineage. So what is this RDD? We are going to study in the upcoming session. Okay. So these are the things your Spark UI shows you. Okay. So you can see the Spark UI only when the Spark session has started successfully. Remember that. Otherwise, you cannot view the Spark UI. Okay. Next. So why we need the Spark UI? Okay. So it helps in debugging. So since you can see everything there, you can debug if anything happens. So you can go to Spark UI and you can view that. So which job failed, which job is running, which job is stopped, everything you can see. It helps you in debugging and also in performance tuning. Okay, you can improve the performance. You can see the storage, right? Storage and all. So by seeing that, you can improve the performance. You can do something which takes less storage, something like that. Optimizations you can do, and you can understand the execution flow properly. Since you can see everything in the UI, you can understand the flow properly. Okay. So we have some DAGs and stages. We will see that later. And we can also monitor the memory. You can track the storage and memory usage per executor. Which executor is using how much memory. So if this executor is consuming so much memory, I'll delete that and I'll replace it with the other one. So like this, you can analyze the things. Okay. And you can also see the task distribution, how the task has been distributed to different workers. All these things you can view in what? Spark UI. Okay. So it helps you in seeing everything. You can see each and every flow, memory, storage. It helps in debugging. Everything it can show you. Okay, regarding the jobs. Now coming to RDD. So I told you about RDD once. So what is this RDD? It is a kind of data structure in Spark. Okay, RDD is the fundamental data structure in Spark. So what does it do? It is a distributed collection of data which is spread across multiple machines. See, in distributed processing, what we are doing? We are breaking up the single task into multiple tasks, and those multiple tasks will be running on the multiple machines. Okay. So you have to collect the data back. So you distribute the tasks and data. Again, once after the processing, you have to collect it back. Then you can display the output, right? So this is the special data structure, okay, which helps in this process. Okay, a distributed collection of data which is spread across the machines, multiple machines. Okay, and the important features of this RDD is fault tolerance. Okay. So lost partitions are automatically recovered from the lineage. So if any data is lost, I told you Spark is a fault tolerant. So how Spark is fault tolerant? It is because of this RDD. You can think like this. Okay. So because of this RDD, you can recover back the lost data automatically. So this is one main feature of RDD. Then what is the other feature? Data is stored in RAM for fast access and computation. Here the data is stored always in RAM. So whenever you want the data, it will be easily and fastly available. Okay. So these are the main features of RDD. RDD is nothing but it is a fundamental data structure which is used in Spark. Okay, since we are doing distributed processing, we don't need a normal data structure. We need one special data structure. So that special data structure is RDD. Okay. What are the key properties of RDD? It is immutable. Okay, once you create the RDD data, it cannot be changed. Okay, so transformations, if you are doing any transformations, then that will again create the new RDD. The same RDD cannot be modified. Even though if you want to modify, a new data will be created. Okay, and it is distributed. I told you data is split across the nodes in a cluster for parallel processing, and fault tolerant. Okay, I told you it is a fault tolerant, and lazy evaluation. So what do you mean by lazy evaluation? Transformers are not executed until an action is called. That means I had to call the action. Then only the transformations or something will be executed. Without calling, it will not do anything. So that is called as lazy evaluation. Okay. In memory computation, data stays in RAM for ultra fast processing. So these are the important key properties of RDD. Why we need RDD? These are the reasons. Okay. How do you create the RDD? So first you have to, these two lines are fixed. So you have to import Pyspark SQL from, import the Spark session from Pyspark SQL. That is the first line. Then in second line, what you are doing? You are creating the Spark session. Okay, this is fixed. And here we have two methods of creating the RDD. One is from the Python collection, another one is from the external file. So first we shall see how to do it from the Python collection. So here I take one variable RDD1 is equal to spark context parallelize. Why I am using parallelize? Because I am distributing this data on the all the CPU cores, right? So that's why I am using the function parallelize. So here directly I am giving the data. My data is what? 1, 2, 3, 4. This is my data. I am doing the parallel processing on this data. Okay. In the next line, what I am doing? First I distribute the data, then I collect the data back. That's it. Simple task. First distribute the data to the cores, multiple cores. Since I have only one system, I can distribute the data on the cores, not on the multiple machines. Okay. So first I create the RDD. What do you mean by creating RDD? You are distributing that to the multiple cores. Then once you do the distribution, again you have to collect. Then only you can print it. Without collecting, you cannot. If you just print RDD1, it will not print. You have to collect it. Then it will print. In normal variables and all, what do? You assign a is equal to 10, print a. So variables value will be printed. But this is the special data. RDD is the special data. So without collecting, you cannot print the content of the RDD. So that's why I have used print RDD from list RDD1.collect. Whatever the variable you are using, RDD1, RDD2, whatever, use that variable and collect. Okay. Now the data is collected and printed on the screen. Okay. This is method 1. So when you go to method 2, you are creating it from the external file. So the same data, I will store it in the file data.txt. Then I give that file to the RDD to create the RDD. Okay, that is the one difference here. Here I have taken one more variable RDD2. Okay, same line spark context, but instead of parallelize, what I am using? Text file. Instead of parallelize, I am using text file. Why I am using text file? Because my RDD data is present in the file data.txt. If you don't want to use the text file, directly you can give the data with the help of parallelize. Okay, two methods. Then Here also you have to collect it and display the data. Whether you are using the text file or directly you are giving the data, but you have to collect it for printing. Okay. Then after everything is finished, you can stop the Spark session because Spark will be running in the background. Okay. Until you stop it, it will be running. Okay. So once you finish your execution, everything, it is better to stop the Spark. So how do you stop the Spark? Spark dot stop. This is the line to stop the Spark. Okay. So here these are the methods of creating the RDD. You came now. Okay. So this was the first method, right? RDD from Python collection. Same example I have shown here. RDD is equal to spark context parallelize. Okay. Then print RDD output RDD dot collect. Okay. So here Spark context, why we are using? This is the core of Spark for RDD operations. Spark context is nothing but it is the core where RDD operations will be carried out. So that's why we have to use Spark context. Spark we know. Spark we have used it to create the Spark session and all. After Spark we have to use the Spark context. Why we use Spark context? Because this is the core of the Spark where your RDD operations will be done. After that, parallelize. So this creates the RDD from a Python list. So you have to give the list, remember. List, you know lists in Python, right? So always give the RDD data in the form of list. Okay. Then RDD collect, what it will do? It will fetch all the elements back to the driver. Okay. Collect means what? Collecting. Okay. Parallelize means what? Distributing everything to run parallelly. Okay. So this is the line, one more important line you have to remember. Okay. Spark context dot parallelize. So inside parallelize, you are giving the data. Any data you can give, not necessarily this data. You can give string, integers, you can give one list in another list, nested list, all the things you can give. Okay. Then this is the text file. Okay. So here we are reading the data from the text. RDD is equal to spark context dot text file data dot text. You concentrate only on this line. Okay. So remaining all we have done it, creating the Spark session, everything. So after you collect, after you process the data which is present in data.text, what you are going to do? You are going to collect it and you are going to print it. Okay, this is the second method. Okay. Now we will see some of the RDD transformations. That means right now what we see, what we have seen, creating the data and collecting it back and displaying it. That's it. But what if you want to do some transformations to that data? What we can do? These are the possible transformations. Okay. I told you RDD is immutable, right? You cannot change the RDD once it is created. But you can do the transformation which will return a new RDD. It means same RDD I cannot modify. Even though I want to modify it, a new object, new RDD will be created. Same object I cannot modify. Okay. So that's why we say RDD is immutable. Okay. So what else we can do? We can use map function. Okay. Apply a function to each element. So for example, my RDD has 4 elements, 1, 2, 3, 4. I want to apply any function, like you know lambda functions in Python. So lambda functions are very small functions which can do only one task at a time and they don't have name. Okay. So here what I am doing, for each element I am doing the square. That means lambda x colon x power 2. That means for that 1, 2, 3, 4 elements what I have created, for all those elements I am doing to the power of 2. So with the help of which function? Map function. Okay. Then what else you can do? You can filter the elements based on some condition. Let us say I have some 10 to 20 elements, okay, in my RDD. I want to filter out only the elements which are greater than 10. I want to filter. You can filter the elements. Give some condition. less than 10, greater than 10, any condition you give, based on that condition, your elements will be filtered. Okay, then what else you can do? Flattens the output, the function flat map you can use. So you have seen ravel, flatten in numpy. Do you remember ravel, flatten, all the attributes? So flatten is nothing but, if your data is having two dimension, it will be converted into single dimension. Flatten. Okay, it will flatten. Okay, and distinct, if you want to remove the duplicate items, you can use it. You can use distinct to remove the duplicate items. Okay, these are the different transformations you can do with the RDD. Okay, what are the actions you can do? What are the actions you can do with the RDD? Collect we have used, right? So we have collected and we have printed the output. Okay, so collect returns all the elements of the RDD. Then what else we can do? We can count the number of elements, and we can display the first n elements. Okay, if I want to display only first three elements, I can do RDD dot take 3. That means it will display only first three elements. 1, 2, 3 only it will display. It will not display rest of the elements. And also you can do reduce. Okay, so if you want to reduce, for example, I have 4 elements, 1, 2, 3, 4. I want to reduce it to one element by adding all the elements. 1 plus 2 plus 3 plus 4. How much you are going to get? 1 plus 2 is 3. 3 plus 3 is 9. 9 plus 4 is how much? Any one number you will get. That number you will get as the output. Here what we are doing? We are reducing the number of elements into single elements. These are the actions you can do. So these are the transformations, and these are the actions you can do with the RDD. Okay, just like built-in methods. For example, if you take list, you have some built-in methods. If you take tuple, you have some built-in methods. In the same way, here also in RDD, you have some built-in methods which will do the actions, which will do the transformations. Then coming to data frames, we will take up in the next class. Okay, now you practice this much. I will give you the set of tasks. Okay, try the task. First create the Databricks account. Once you create the Databricks account, start the Spark session there. Just now I showed you in the same way, start the Spark session. Then start doing the tasks. Okay, so I'll post the task in the classroom. So once you get it, you can start doing. I have a tasks here.